Hello everyone, this is Vasishta from aerobie section. Today I am going to explain about variance and coefficient of variance from a concept video of a P&S. So, coming to the main topic of variance, first we need to know about variation. Measure of dispersion or variation. The variation or dispersion in a set of values refer to how spread out the values are from each other. The variation is small when the values are close together. There is no variation if the values are same. So, as we can see, there is a larger variation between these values. When there is no when they are close to each other, we can know it is as smaller variation. We have a graph here regarding larger variation and also smaller variation. So there are some types of measures of depression, which are range, variance, standard deviation, coefficient of variance, etc. So coming to the range, we know that range is a largest maximum or the difference between the largest maximum and the smallest minimum value, where range is equal to maximum minus minimum, and where as we can see there is an example regarding it, which is 26, 25, 35, 27, 29, 29, where 35 is the maximum value and 25 is the least value. Then the difference between it is 35 minus 25, and this is not useful for measuring of variation. So next, coming to our main topic, variance. The variance is the measure used to uses the mean as a point of reference. The variation is smaller value when the all values are close to mean. The variation is large when all values are spread out from the mean. So as we can see, when we find out the value of a mean, if we find out the value of a variance, and we can see that as we have to center the mean as a main point, where if we measure the variance, if the value we are getting is compared close to the mean, it is a smaller variance. If it is large, it is a larger variance, which is a squared deviation from the mean, which is x1, x2 and x bar, and also x, where x1 minus x bar whole square and x2 minus x whole square and xn minus x bar whole square. We have two types of variance, which is a population variance and a sample variance. What is a population? In population variance, where x1, x2, x3 and so on xn with the population values, the population variation is defined by sigma of sigma square is equal to I equal to 1 summation of n xi minus mu whole square by n, where x1 minus mu whole square plus x2 minus mu whole square plus and so on xn minus mu whole square divided by n, where mu is the mean and n is the total number of observations. The capital N is the total number of observations, where mu is equal to I equal to 1 summation of n xi by n is the population mean, where sigma square is the parameter because it is obtained from the population values. It's unknown in general, where sigma square is greater than or equal to 0. Sample variance, where we know that sample variance, in sample variance x1, x2, x3 and so on xn are the sample values, where the sample variation is defined by the s square is equal to I equal to 1 summation of n x1 minus x bar whole square by n minus 1, where x bar is the mean in sample variance, where n minus 1 is the total number of observations, where small n is the sample mean, sample space, where x bar is the summation of I equal to 1 xi by n is the sample mean. S square is a statistic because it is obtained from the sample values, and S square is used to approximate estimate that S square is greater than or equal to 0. We have an example regarding a sample space or sample variance. If you want to compute the sample variance of the following sample values 10, 21, 33, 53, 54, where n equal to 5 is the number of values we have, where coming to that problem, x bar is equal to summation of xi by 5 if we have to find the mean, and also s square, that is xi minus x bar whole square, the summation. The total number of values can be determined by using this s square. And we have another method regarding the same problem. As we can see, xi. The values of xi can be determined with 10, 21, 33, 53, 54 and so on, where xi minus x bar and xi minus x bar whole square. The summation of xi minus x bar whole square divided by n minus 1 is the answer we get on the previous method. So this method is simple and more accurate, which is the summation of I equal to 1 xi whole square minus n into x bar whole square by n minus 1. So from the note, we have to calculate s square we need. N is equal to sample size and summation of xi is equal to the sum of the values, where summation of xi square is equal to the sum of the squared values. From the previous example, xi is 10, 21, 33, 53, 54. Xi summation of xi is equal to 171, where x square is equal to summation of x square with x, the formula s square is equal to summation of xi square minus n into summation of x bar whole square. So, not summation, only x bar whole square divided by n minus 1. If we substitute the values, we get the same previous answer. So standard deviation, we all know that standard deviation is the root of variance, and for population deviation it is sigma is equal to root sigma square, and for sample standard deviation it is equal to root s square. So next, coming to our main topic, coefficient of variance. What is the coefficient of variance? Coefficient of variation is nothing but the ratio of a relative standard deviation to the mean. The variance and the standard deviation are useful as measures of a variation of a values of a single variable for a single population. If you want to compare the variation of two variables, we cannot use the variance or the standard deviation, because the variables might have different units, the variables might have different means. And the formula for coefficient of variation can be determined as C is equal to sigma by mu, or CV is equal to S by X bar. For percentage, CV is equal to sigma, CV is equal to sigma by X sigma by mu into 100 for percentage of a coefficient of variation. So we need to measure relative variation. This will not depend on either the units on how large the values are. The measure is the coefficient of variation, which is defined by CV is equal to S by X bar into 100. As I have said earlier, this is the formula regarding the coefficient of variation. And first set data. For example, if you take first set data and second set data, we need to take two sets of data for coefficient of variation, which is x1 bar and x2 bar. The formulas will be CV1 and CV2. The relative variability in the first data set is larger than the relative variability in the second data set if CV1 is greater than CV2, and as vice versa. For example, in first data set, if we find C1 V1 is 6.8% and the second data set it is CV2 12.5%, that is CV1 is less than CV2, the relative variability in the second data set is larger than the relative variability in the first data set. So some of the properties of x bar, s and s square. And sample values are x1, x2 and so on xn, and where a and b are constants. So there is an example regarding sample data, sample mean, sample standard deviation and sample variance. X1, X2 and so on, and AX1, AX2, AX and so on. Where for sample mean of x1, x2 and so on x is this x bar, and a sample standard deviation is s, and a sample variance is s square. And the absolute value mod a for ax1, ax2, and so on axn Ax bar and the sample mean is Ax bar and the sample standard deviation is mod A S and the sample variance is A square S square, where mod A is the mod A is the limit between A and minus A, where A is if A is greater than or equal to 0 and minus A if A is less than 0. So this is an example regarding a sample, and a sample means sample standard deviation, sample variance and coefficient of variation. So we all have a doubt regarding, can CV exceed 100%? Yes, if we take these values data of 10, 1, 10, where a mean is 10, 1, 1, 0, where a mean is 3 and a variance is 22, the standard deviation is 4.6 something. So the coefficient of variation exceeds 100% with 156.3. So the answer is yes, we can exceed the coefficient of variation to 100. So this is all about my explanation on variance and coefficient of variation. Thank you.